Alright, I owe you guys another demo. I think I have some pretty cool stuff to show for this past month. So last month I demoed how I have this new tooth trimming capability, which I have on display right now, where after you design your teeth, the gears are rolled together and the outer peaks are trimmed back to make sure that any tooth collisions are cleaned up and avoided. You can see if you watch here the peaks receding. But I didn't show that there is a little bit of setup work that has to be done before you get to this point, and a few other concerns that are necessary. So this past month I've been building up some of the supporting capability and workflows to actually make this possible in all circumstances. Consider the following gear assembly. Here I have a single one lobe symmetry, another one lobe symmetry, a two lobe symmetry, and a rack and pinion gear. And the interesting thing is that there are many different ways to actually pair these up. For instance, I can hide these two and have these two gears paired together externally. I can also have these two gears paired together, but in this case I need to invert the orientation to an internal gear for the two lobe symmetry so that this gear rolls along the inside. Another scenario I have is I can take that rack and pinion gear, can hide this, and in this instance I think I still need to reverse this guy. There we go. Now I have this gear rolling along the right side of the rack and pinion gear, but also I can put this one back, flip this one again, and I can connect this gear on the opposite side to the rack and pinion. So depending on if you invert the gear from internal to external, you can connect gears on one side or the other. So the question becomes, if I actually want to roll the gears together to trim the teeth back, how then do I determine which gears are paired together? So to handle that, I had to implement basically an instance selection workflow. And you have this little box of gear instances. This is before you do the actual trimming, and you select which gear you want and you say add selected. So now that's our starting gear. A little rotation there. Now I get to choose which gear I actually pair up with it. And if I want, I can select, say, my rack gear. And notice I'll actually remove this. I'll say, click this guy and say delete. If I were to invert the rack gear before I try to add it, it will not let me add it because that is a invalid pairing. It needs to be reversed before I can actually add the selection. And likewise, delete you. If I were to use the other gear as a starting point, then if I try to add the rack in its normal external state, it would not allow me to add it. But if I flip it, then it allows me to add the gear. So it allows you to actually perform the pairings of the gears so that you can say, all right, I'm done editing my instances, and there we have the assembly ready, and I can say begin trim, and it'll actually start trimming the peaks wherever any collisions occur. I also now have this, doesn't seem like there are too many, well there are a few, but I also have this new trim accuracy toggle so you can make that trimming fast or slow, If you're just trying to get a quick idea of how it looks, then you can use the fast trimming, but you may want to go back and do a slower trimming for something if you're actually going to export it. But as a basic quality of life feature, if you have only two gears and they're paired up in a way that's compatible with each other, then if you click next, it will automatically populate the instance tree without you having to actually manually define it, because I think this will be the more common scenario and I don't want the user to have to waste time doing something obvious. Here is another necessary workflow I implemented. So I know a lot of people are excited about the open arc and rack gear capabilities in version 2. And in order to support these gears and to allow for trimming, I do have to compute an enclosing of these open shapes. In other words, this exterior frame and how it connects to the actual tooth outline at the ends. Gearify does automatically compute that outline, but in this sort of contrived example here, I've shown an example of where the automatic calculation fails. I will say this is maybe 2% of the time, so this is a very rare edge case scenario, but I do need to allow the user to fix it in the rare event that it does occur. So here is how I would handle that. I go to Define Extents, and I select the gear that I'm interested in editing. Now what I can do first here is I can actually define what subset of the teeth I want as my starting outline. I'm going to define it to be just a little bit different from what it was. Just clip off the ends a little bit. Say update. Now notice when I say update, it actually recomputed the outer frame as well, which is the other half of the story. Okay, so now I made it worse, but that was only because I only edited the tooth extents. Now I'm going to just say define frame, and now I actually have some control over what this frame looks like, and I can add vertices, and I can also delete vertices as well. So now I've actually modified and fixed. Let me say done editing frames. Good. And now that I have this modified to something that actually makes sense, I can proceed to actually do my tooth trimming using this outline. This is a rare workflow, like I said. Most of the time you won't have to use it. You'll never have to use it if you're using closed loop gears. But if you're using the open arc gears, you will occasionally need to perform these edits. Here's a nice example. Here I have fashioned two arc gears to have a 360-degree arc with fairly distinct ends to actually produce spiral gears. Now notice where I stopped it. You have this considerable interference at the ends, this area right here in particular. Now you can to some degree handle that with the tooth trimming, but rather than doing that, you may just want to change the actual extent of which of those teeth are used for this gear. So I think what I want to do, if I back this up, is actually have this gear terminate at this tooth end right here. So I'm going to select this gear, define extents, and just click once, and then click again. Update. Alright, I'm going to leave the other as it is, only I'm going to modify this frame a little bit. There, that looks a little bit nicer, like so. And then for this gear, modify you just to make it look a little nicer. Done editing frames. And now, if we look at it, we see we have a more reasonable assembly where it just kind of picks up right there. Now these sorts of gears are much more for like decorative or artistic purposes. This is not very practical for like a high-speed machining type of scenario, but some people may want to make these for kinetic art reasons and whatnot. All right, and the last thing I want to show is that suppose when you're doing your exporting, you want the size of the exported design to achieve a certain desirable dimension based on one of the gear sizes or reference dimensions. For instance, perhaps you want the minimum or maximum radius of this red gear to correspond to a particular dimension. Maybe you want the minimum radius to be 4 inches or 4 centimeters or what have you. Or maybe you want this distance from this gear to this gear to be 6 centimeters. So how do you handle this? So there is this new scaling window. And the idea of this scaling window is that you can set a reference dimension, and then you can scale it such that your reference dimension equals a desired dimension. So here I say ref1 min radius. That means whatever your ref1 gear is, which is A1, which is this red gear. I'm saying that I want to scale it such that my A1 min radius will correspond to 1 unit, but I can change it to what I want. Say, let it correspond to 6 units and scale the dimension. Now when I do the export, the design will be scaled such that the minimum radius of this gear, which will probably be about that dimension there, will correspond to 6 units. Another example is maybe I want one of the gear center to center distances to correspond to a particular dimension. So for instance, let's say I choose the B1 to B2, set those as my reference gears, and I say I want my ref1 to ref2 distance. I'll set that to 4. Say scale to dimension. And now I'll do an export real quick. Gear export March. Save. Let me open this in LibreCAD. Gear export March. All right, and now let's actually just go and measure that distance as it turned out. And you can see here it says that the Cartesian distance that I just measured is 4 inches. All right, I'm going to stop it right there because this video is getting long. But the good news is that all the feature dev is done for the release. Now it's just polish, just trying to clean things up a little bit, make it a little more user-friendly, you know, reshuffling a little bit of the user interface presentation a bit, adding tooltips, things like that. So we're in a really good spot now. I'm pretty confident by next month I can have the polishing done and then move into actually trying to get the release out so that people can start playing with it in beta form or what have you. So, all right, thank you for watching. I'll check in again next month.